Welcome to The Explainer. Today, we're diving into one of the biggest, most exciting shifts happening in AI, agents. We're talking about moving from AI that just answers a single question to AI that can actually take on entire projects for us. So, what exactly makes an AI an agent? And how is this changing basically everything? Let's get into it.
And hey, don't just take my word for it. The legendary AI pioneer Andrew Ng says this is a trend that everyone in the field needs to be watching closely. And he's right. This really gets to the heart of it all. AI is evolving from just being a tool into becoming a genuine autonomous partner. So, what is the big deal here? Well, up until now, most of the ways we've used AI have been what you'd call non-agentic. You give it one prompt, you get one answer back. That's it. It's kind of like trying to write a whole essay in one go without ever being able to use the backspace key. But this agentic workflow, it completely changes the game. It introduces this powerful, iterative loop. Plan, act, revise, and then repeat. This is so much closer to how you and I actually think and solve problems in the real world. Okay, to really get a handle on all this, we're basically going to climb a ladder of complexity. We'll kick things off with the agentic shift itself, then we'll walk through the different kinds of agents, from the simplest reactors all the way up to advanced systems that learn and collaborate. And then we'll wrap it all up with the big picture. All right, first step on the ladder, the agentic shift. This is the fundamental move from AI just doing what it's told to AI actually reasoning about its own work. And one of the key techniques that makes this possible is something called the reflection pattern. So here's how that works in practice. An agent performs an action. Let's say it writes a block of code. Then you prompt that very same agent to critique its own work. It'll go back, check for bugs, maybe find a more efficient way to do something, and finally it revises the code based on its own feedback. This simple little loop can dramatically improve the final output. And get this, with no human intervention needed. That right there is the essence of agentic reasoning. Moving on up, let's talk about simple agents. You can think of these as the reactors. They are the absolute foundation of AI autonomy. So the most basic type is the simple reflex agent. It works on a really straightforward if this, then that logic. I mean, think about an automatic door at the grocery store. If its sensor sees motion, then it opens. That's it. It has zero memory of what just happened and no concept of the future. It just reacts to what's happening right now. Now, let's take one step up to the model-based reflex agent. The huge difference here? Memory. This type of agent keeps an internal model, like a little map of its environment. A perfect example is a Roomba vacuum. It doesn't just randomly bump into a chair and turn around. No, it maps the room, it remembers where the furniture is, and it cleans way more efficiently the next time around. That internal model is a total game changer. Okay, so we've gone from reacting to remembering. But what about actually planning for the future? Well, the next level up is strategic agents. These are AIs that don't just see the world as it is, but as it could be. A goal-based agent is designed to hit a specific target. It doesn't just react, it actually plans out a whole sequence of actions. When you ask Google Maps for directions, it's not just seeing your little blue dot. It's considering your goal, your destination, and it's planning the entire series of turns to get you there, all while thinking about things like distance and traffic. And this brings up a really important distinction. A goal-based agent is happy finding a solution that gets the job done. But a utility-based agent asks a much better question. What's the best solution? Its whole purpose is to maximize what's called utility, or, overall satisfaction. An autonomous car doesn't just want to get you from point A to point B. It wants to find the optimal route for safety, speed, and comfort. The focus shifts from does it work to what's the absolute best way to do this. All right, we've now reached the top of our ladder. We're looking at the most sophisticated agents out there today. These are the ones that can learn, adapt, and even work together on really complex problems. This is truly the cutting edge. A learning agent, well, it does exactly what it sounds like. It gets smarter over time. It has a learning component that lets it adapt based on experience and feedback. We've all seen this in action, right? Think about Netflix. It doesn't just throw random movies at you. It watches what you watch, it sees what you skip, and it constantly refines its model of your taste to give you better and better recommendations. But what if a single agent isn't enough for a huge task? Well, you build a team. In multi-agent systems, you can assign different roles to different agents. Maybe you have a researcher, a writer, and a critic, and they all collaborate on one job. This is often done using frameworks like Crew AI that help manage the whole workflow. The final result is way better than what any one agent could do alone. You can even structure this like a company, with a manager agent delegating tasks to a team of worker agents. So, wow. We've climbed all the way from simple automatic doors to complex AI teams that can write entire research papers. Let's just take a step back for a second, look at the big picture, and talk about why this whole agentic shift really matters to you. The benefits here are just immense. I mean, agents offer massive efficiency gains by automating really complex, multi-step tasks. Their adaptability means they can learn and improve on the fly. This lets us scale up solutions to problems that were just too big before, all while that iterative reasoning process leads to way higher quality results in the end. But of course, it's not perfect. We have to be realistic about the limitations. Agents can still really struggle with real-world context and ambiguity. Their performance is completely dependent on the quality of the data you feed them. And yeah, these complex iterative workflows can be incredibly expensive to run. And most importantly, as they get more and more autonomous, they force us all to confront some really critical ethical and privacy questions.
And that brings us to the final and maybe most crucial thought. This technology is moving at an incredible speed. And the biggest challenge ahead might not be a technical one, but a human one. As these agents become more and more capable, the question we all need to start asking is this: how are we going to learn to delegate to them, work alongside them, and ultimately trust their growing autonomy? Definitely something to think about. That's it for this explainer.